Okay, so we're going to go over common factoring. We have our first example here, 4x plus 28. When you're looking for common factoring, you're actually usually looking for the greatest common factor, right? So your GCF. One way to do it is to take your terms or your coefficients and look for a common factor between the two of them. So we have 4 and 28. Right? And we just look through the factors of them. So we have 1, 2, and 4 for the factors of 4. And we have 1, 2, 4, 7, 14, and 28. You were able to tell really quickly that it was 4, our greatest common factor. So that's great. We know the greatest common factor is 4. We actually have to factor this. That's part of what common factoring is about. So what that means is we now bring this 4, which is our common factor. Actually, it might be easier to explain this way. We take that 4 and we're actually going to divide both of these terms by the 4. And it's going to come to the outside. We're going to set up like an imaginary set of brackets around these right now. Okay? In the next line, those brackets will be there. So the 4, which is the greatest common factor, is outside of these brackets. And then, depending on what these equal, these are the two terms that are going to the brackets. So 4x divided by 4. Yeah, well, essentially it's 1x, right? So we can put in our 1x. And then our other one is 28 divided by 4. And what's important to notice is it's a positive, right? So it's positive 28 divided by positive 4. That's actually going to give us positive 7. Okay? Now this would be your answer. Now I'm going to simplify it a little, write the rest in black. So when we're common factoring, the 4 is outside. We don't really have to write the 1 in front of the x. So it would be 4 bracket x plus 7. Now technically, these two things, what we started with and what we have, are the exact same. Just one is written in usually what's considered a standard form, and this is written in more of a factored form. Okay, so we can call this a type of standard or expanded. A lot of times I talk about this being expanded form, so standard or expanded. And down here, this is our factored form. So whenever they're asking for factoring, they're looking for stuff to go into a form like that. Okay, so we have example 2, 6x squared plus 8x for common factoring. So, same idea. I'm going to start with the coefficients, which are the numbers in front of the variables. Okay, so we're going to start with them, and we're going to figure out what pair of common factors will be. So we have 6 and 8. Well, factors of 6 are 1 and 6 and 2 and 3. Now, it usually makes sense to actually put these in order, that way to find greatest common factor, but we can try it this way. If we're having trouble, we can rearrange it after in order of least to greatest. 1 and 8 and 2 and 4. Well, if I look through this quickly, I know 1's a factor, but 2 is also a factor, and it looks like it's going to be the greatest one. Okay, so we're looking at 2 as our greatest common factor. Is 2 in this case. So same idea as above. I'm definitely going to divide each of these by 2. But I'm actually not done because I have variables attached to both of these. Okay, so I'm going to break these variables up so they kind of make sense here. We'll do these in green. One of them is considered x squared, and the other one is just considered x. Okay, well, to make x, you can, when breaking variables up, just think of it as the only things you can multiply by are the variables themselves. So in order to make x, I would have to just multiply 1 by x. So really there's just 1 x involved here. But with x squared, there's 2 x's involved here. Okay. So, and what that means is I can take 1x out of both of these. Okay. Now that same idea would go for, let's just say, we'll make it another example. If I had x cubed and x squared, well, this one consists of 3 x's and this one of 2. So I'd actually be able to take 2 x's out of all of these. Okay? So what really happens here, is a fast way to think about this, is if we have variables attached to each of the numbers and we're going to factor them, we take out the variable with the lowest exponent. Technically, this is to the exponent 1. So I take out the variable that has the lowest exponent, which in this case is x to the power of 1. So not only do I divide by 2, but I also divide by x to the power of 1. I don't need to write the power up there. So that's going to be our true greatest common factor here. Greatest common factor here. Here it was GCF of just x. So the total GCF was 2x. Okay, so we divide each of those by 2x. Same idea. It's going to come to the outside of, we're going to set up our own little brackets here. So to go into factored form from our standard form here, our 2x goes to the outside. And then we're left with what each term is once we divide. So 6 divided by 2 is going to give us 3. And x squared divided by x, or x to the power of 1. I'm not sure if you've gone over this before, but all you do when you have division of variables with exponents is you subtract the exponents. So because this is a 2 and this is a 1, I put 2 minus 1 is 1. Yeah, so I have x to the power of 1. That's the idea. And over here, 8 divided by 2 is going to give me 4. That's right. Well, what actually happens, I don't know if you know this rule at all. It makes it x to the power of 0. Do you know what any number to the power of 0 is? 0. Not quite. It's a good guess, but any number to the power of 0, we'll give you a couple examples here. 100 to the power of 0. All of these equal the number 1. Okay? So what that means is I can replace this with the number 1. And what is 1 times 4 going to be? 4. So we don't really have to include it. But it doesn't technically make a 0, because 4 times 0 would be very different, right? So what happens is it's called creating a 1, is what actually happens here. But you can think of it like canceling out and it drops off. So we're just left with the number 4 there. Okay? But that's the math behind the idea. So our final answer here in factor form is 2x as our common factor. And 3, I don't really need to put that exponent of 1. It's assumed if we don't leave it in. And plus 4. So that's our factored form. So going from an expanded or standard form to a factor. Okay, the next example we have here is a trinomial. This is called a binomial because there's 2 of them. This one's called a trinomial. They want us to find the greatest common factor again. So again, we're going to look at the coefficients, right? 10, 15, and 5. So what I could do is I could write out the factors of 10, 1, 2, 5, and 10. Factors of 5, which are 1 and 5. Factors of 15, 1, 3, 5, and 10. What's going to be the greatest common factor there? See it? 5. Yeah, 5 is going to be the greatest common factor. So I'm going to divide all of these, all 3 terms, by 5. What about in terms of our variable? I have an x cubed, an x squared, and an x, which essentially they consist of x, x times x, and x times x times x, right? So how many x's can I take out of each of these? 1. I can only take 1 out, right? And really that plays to our rule is I take out the variable with the lowest exponent if there's a variable involved. So I got 5x, 5x, and 5x. Now I can leave it like this, but a lot of times what they want us to do is if our first term is a negative, they actually want us to take out a negative value in all of these. Okay? And it can sometimes be very helpful. So we're actually going to try that here. We're actually going to take negative 5x out of everything. And just to see how that's going to change our operations a little. So I'm left with negative 5x outside of the brackets, right? Now, in the brackets, now I want you to read this like this. Negative 10 divided by negative 5. If I have 2 negatives dividing, what type of answer am I going to have? Positive. What number? Well, it's 10. Negative 10. Yeah. Good. So we have positive 2. What about in terms of my variables? 2x. Yeah, well, or x squared. Yeah, that's right. We take the exponents, 3 and 1, and subtract. Now, same idea here. I have positive 15 divided by negative x. What will I end up with? What type of answer? Positive divided by a negative? Negative. And 15 divided by 5 is actually going to give us 3. You did 5 divided by, or 1 divided by 5. And what about our exponents? 1. Yeah, x to the power of 1. And finally, in this one, 5x divided by 5x, what is that going to create? Yeah, and there's a negative divided by a negative, so I'm going to have a positive 1 as an answer. So just to reiterate the answer on black here, negative 5x is our greatest common factor, and inside the brackets we have 2x squared minus 3x plus 1. So you can find a greatest common factor for 3, sometimes 4 or 5 different terms.